Doing well? There you go. Okay. So, I wanted to keep working on this. The answer is 0. Well, if they give us the answer is not 0, so I would be surprised if it was. Yeah. No worries. So, wait, what? You know, actually, that's fine. See, so those two integrals cancel each other because of this is an even function and they're oriented in opposite directions. These two integrals are the ones that make life worse. We can say these two integrals are the exact same thing, I think. And just combine them to be 2 times that. With this one, I assume we need to play around with it, unfortunately. So I'd started to do a sum identity for sine. I want to multiply out the bottom to see if that gives anything nice looking. And so those -1 + 1 cancel. I really don't want to do a whole bunch of writing and rewriting. You know, honestly, maybe it's better to keep it like this, keep it factored. Could raise the stakes a little bit and bring an X out. I don't know why that's raising the stakes, but go with it. This is stupid. I should instead think about a change of variables, I think. The thing is, it's going to make the bound different, and I'm not a fan of that. I don't think we can justify that they cancel in it in any way. They should, like, if I'm going to say that these two here add, then these two here should also add. Let me just write what that one looks like with that change of variables. Hey, Gizmeist. Hope you're doing well. If x starts at r, then u starts at r plus I. Goes to epsilon 2 plus I. Sine u over u, u squared plus 1. du. So the point of this is the inside looks almost exactly the same as this. The issue is the bounds are different. I have a major in applied math, minor computer science. The thing that I'm working on right now is from complex analysis. Trying to work on an integral that complex analysis can help with. Um, telecom engineering and it sucks. Looking for a program in applied math and computer science. Oh, that's convenient. Uh, I guess not too much advice, to be honest. Like if you're more interested in that, I think then yeah, you should go for it. My experience with graduating and applying for jobs was terrible. I could not get a job with my degree. And I think it might have helped to stand out if I tried to do some type of like projects or something to stand out a bit more than just having a degree. So if you're studying that with a job in mind, then I wouldn't automatically assume that that's enough to land you a job. In my experience, maybe if you're better at selling it than I am, then you can. But I did not have good luck. That was also like 6 years ago or 7 even, and I haven't like really seriously tried to apply again since. So maybe things have changed. Hey Mo, hope we doing well. Yeah, like so honestly, there weren't a ton of jobs that I saw that were like a perfect fit specifically for applied math type of people. I was applying to pretty like software engineering type of jobs. What I would do is just go on Indeed or something and just look at what types of jobs you might be interested in and the types of things that they're asking for, and that can help really like focus what you learn. Rebuild was fun. Um, yeah, it wasn't as crazy as that other night, but it was just kind of like a normal, I guess. Pranav, how to solve vectors? Can you be more specific? Like, can you give me an example of a problem? Studying telecom engineering, probably land in a job, but honestly, it sucks. Not having a good time with the courses. Talking about signals and those things. Yeah, I bet those aren't easy. Uh, yeah, the things that I learned as part of my applied math were like differential equations and modeling. And there are jobs that involve those, but there's not as many of them. Sitting counts, I want to know more about math before you jump into it heavily. Oh, nice. We'll sleep early, seating on. Yeah, fair. You don't understand dot product and cross product? Okay, we can talk about those. visually. Okay. So let's start with a dot product. Sounds good. See you soon, Mo. So if you have two vectors A and B, we might say that A dot B, and let's say our vectors are two-dimensional also. So before I even write that, let's say that A is equal to A1, A2. These can just be any number you want, like 1, 0, or 2, 10, whatever. And let's say that B is equal to B1, B2. Then their dot product is equal to the x component times the x component plus the y component times the y component. And I'll get to the visual part in a second. And the same pattern holds for like vectors with more dimensions. So if they were three-dimensional, you just add on A3, B3, and so on. There's also this other formula for the dot product, which is actually I should, before I even say that, I should point out this is a scalar. The result of the dot product is not a vector, it's just one single number. You're getting good grades on them, but I really think I can do better on applied math. TBH, you might working on OpenAI or Claude Team. Ooh, nice. Yeah, AI is probably a good application of applied math that wasn't very popular when I was applying to jobs. The mini course of 3 blue and brown about linear algebra is fantastic for understanding vectors. Oh yeah. Guess you might like Penn Center, I think on Fridays. Maybe even you might have missed it for today, but he's doing like a summer machine learning kind of like study together thing. So if you're interested in like learning a bit more about that, you could try to follow along with that. I don't think it's very deep in. It's also being talked about in his Discord, which is called the Elements. I think this is the command to get it. Is it Penn Center? Dang it. Is EnigmaBot even here? Oh, it's not. EnigmaBot is down. Okay, if you go to his Twitch page, you could have a link to his Discord. But that might be a thing that you're interested in too. Yeah, no worries. Because I know that he likes machine learning a lot too. He's actually the department chair of math at a community college as well. He's just a good person to know. Okay, so sorry about the dot product. So the dot product takes two vectors, turns and spits out a scalar. The other formula that I mentioned was it's also equal to the magnitude of A times the magnitude of B times cosine of the angle between them, which we just call theta. And the important thing, and this is a really significant formula because this is where the visual part of it comes in. Theta, the important thing to remember about theta is that cosine of 0 degrees is 1, or radians, it doesn't matter. And cosine of 90 degrees is 0. And so because of this, and like between and of course between 0 and 90 just kind of like varies continuously. And that's important because that means the dot product in some sense gives you a measure of how in line these two vectors are. If you take two vectors, like if this is A here and then B is exactly in line at the same angle, then the dot product is the highest it can possibly be because we have cosine of 0. And that dot product will come out to be just the magnitudes multiplied. Whereas the least the dot product can be is if they're perpendicular. Because cosine of 90 is 0. And so this will, if two vectors are perpendicular, it doesn't matter what their magnitudes are, you always get 0 for the dot product. And that's a really useful thing in applications, actually. Like if you have like an electric field, like let's say this is like a positively charged particle here. Its electric field looks something like that. In physics, you're often asking like, how much work am I doing if I travel from this point around here and end up at this point? And there's basically a way with integrals that you can take. This is a little bit advanced, so don't worry if you don't understand every last step of this, but I'm trying to get across the point where we can use dot products to measure how in line this path is at each point with the electric field that particle is producing. So like, you could draw like if you're interested in like maybe that point right there, you could draw a vector that looks like that and dot it with the electric field. It looks pretty perpendicular, so you're not doing much work. Whereas I could find a point, I didn't draw the path that well, but a point like right there, where it's not really, I mean, it looks a little bit perpendicular. It's a bit, dang it. I could have drawn my path a little bit more wisely. Like that point right there is pretty in line with the vector field and will give you a pretty high amount of work. So that's what the dot product does. Like the most important thing it does is it measures how in line two vectors are. Let's say you, a person with applied math knowledge, wants to dive in AI machine learning. Would it be easy to you to get into with the tools you have from math? I definitely have the background knowledge necessary. And I can talk about the cross product in a second here. But I couldn't just hop into it right now without doing extra studying. AI is kind of a specific application of math that I would need to learn the math that is particular to that for. But as I understand it, it is a lot of linear algebra. And I don't think it would take that much more studying to be able to get into it. There's also like, there's different, like, you know, AI is on a spectrum of things that you do with it. You could be developing the AI, which requires a lot of the math knowledge, or you could be applying the AI, which would be more of a coding task, like software engineering. So it's not just like, if you work in AI, you could be doing a lot of different things. Okay, so what the cross product does, the cross product is a little bit more complicated. It only really works for three-dimensional vectors. It might also work for like, there's something weird where like it works for like 7 dimensions, but it doesn't work for like 4 dimensions. The cross product is a little bit weird. You tend to actually drop the idea of the cross product the deeper you go into math, or you kind of redefine it in a different way. But let's get our 3-dimensional vectors here. And if you only have two-dimensional vectors, you can always tack on a 3rd dimension and just make it 0 if you need to use a cross product in 2D. But we're going to start with just regular old 3-dimensional vectors. Oops. What the cross product does is it takes 2 vectors and it gives you a 3rd vector. That 3rd vector is perpendicular to them both. So if I were to start with, actually, if we do start with some 2-dimensional vectors, let's say I have that vector A and this vector B, the cross product of those 2 vectors comes out perpendicular to the page. And there is already a slight annoyance here where is it coming perpendicularly towards me or away from me? And there's no good answer to that question. We just have to arbitrarily choose one. And the choice that we conventionally make is the one that comes out towards you. It's called the right hand rule. It's really hard to show this on camera Um, it's a lot easier to show in person, but basically make your hand flat, point it in the direction of A, and then curl your finger towards B. And then wherever your thumb points is where the cross product points. And again, that's very hard to express over a stream like this, but that's kind of the idea of it. And so the cross product is most often used for things like you're given two vectors and you need to find a third one that's perpendicular. Like if you have the equation of a plane, you're often interested in the normal vector to that plane, and you can use the cross product to find it. You can actually calculate the cross product. You need determinants. Well, you don't need them, but that's how that's usually presented, because if they just showed a formula for it, it's really complicated looking, but the determinant is pretty easy to set up. And then you need to know to take determinants, which is the unfortunate bit. But you set up a 3x3 matrix. The first row is ijk. The second row is a1, a2, a3. The third row is b1, b2, b3. And then you take the determinant of this matrix and expand along this row. And so you'll get a2, a3, b2, b3, I hat minus a1, b1, a3, b3, j hat plus a1, a2, b1, b2, k hat. And then you need to do those two by two determinants, which I don't want to write all those out, but that will give you a vector where whatever goes with I is your x component, whatever goes with j is your y component, whatever goes with k is your z component. Unfortunately, this trick only works with the ijk notation and not this notation I was using up here. It's all the same, though. The only other thing to state about the cross product, it's not really used as commonly in applications, but the cross product has a similar formula. The thing is, this cross product has a similar formula as this thing. The thing is, it's not quite as convenient because this only gives you the magnitude of the cross product, not the direction. But the magnitude of the cross product is equal to the magnitude of A times the magnitude of B times sine of the angle between them. And so because now it's sine, you could think of the cross product as measuring how out of line things are. So if things are exactly perpendicular, the cross product will be at a maximum magnitude. Whereas if they're exactly in line, the cross product is actually 0. Guess that's the part I would like to be. It sounds very satisfying to be in the field and apply math to solve problems like how to make a better algorithm, how to build a better way to teach the model, how to get better answers according to data we have. The coding part doesn't sound fantastic to me. Just like a part that can be done just because the scientists before developed what to do. Yeah, that's fair. And so like you could also like get into like the data side of things, which doesn't have to involve AI, but it certainly can involve AI. Like there's data science degrees too, or like programs out there that might also like catch your interest. Yeah, no worries, Pranav. Let me know if you have anything further you want to hear about. But yeah, so I'm not personally super interested in AI, but I do feel similar to you in that I love seeing where math can actually help solve problems for you. If I don't see the motivation behind math, I tend to lose interest in it. So I was replying to a text. Okay. Sorry about that. Let me actually check. Is Pen Center streaming? Oh no, he is streaming. I bet he's doing the machine learning thing right now, Gizmeist. Let me actually look, because I'm curious to see now. Yeah, he's doing machine learning right this instant. So if you want to go over there and say hi, I definitely do not blame you. Okay. In the meantime, I'm going to return to my contour integral attempt here. I'm just kind of checking. Did I do this right? I'm checking my calculation for C epsilon 2. I feel like I'm missing a negative sign. So it's z cubed plus z. Take the derivative, so it's 3z squared plus 1. Then you plug in I. So that should be a negative 1, I think. Which means it's minus a half. Hey, Jasu. Hope you're doing well. Spend the day answering reviewer comments. Oh, God. Did you get through them? Or is there like a lot? Hey, Sakno. Oh, you know what? Sakno, I did find another streamer. I don't know if you know them, but you might be interested in them. Econ Greg. I believe he has an economics PhD. And he's also interested in like philosophy and quantum field theory and some other things like that. I can't really vouch for him. I only watched his stream once, but just I seeing him just like made me think of you with how you're interested in kind of like economics and ethics and stuff. So yeah, no worries. It's going well. The shock of being sent to the biggest person in the field is still present. Oh yeah, I remember. Yeah, yeah, I wasn't able to fully like ask you about that yesterday because I was talking with Fembox and Slim and Mouse. That's cool though. Like I hope they didn't have too many negative comments because that would be a little bit deflating. Hey, Syntax. Uh, A run. Is that a competition integral? The comments are negative, just clarifications. Oh, well, that's great then. If my paper got sent to like the biggest person in the field and they hated it, I would feel terrible. What? Yeah, I mean, that's a pretty good sign if it's just clarification. Well, it's not really this isn't the exact integral that they asked about. I'm not exactly sure what they're which integral they're talking about because they put two in there. I think one is from 0 to pi over 2, the other one is from 0 to 2 pi. Around that looks like an integral that's going to be beyond me, probably. So sorry, but I don't think I can do that. How to start derivations or integration questions which are too complex and aren't from direct formulas? That's a very big question, Hurricane. Derivatives are you can almost always do derivatives even for weird looking functions. Like maybe yeah, I mean there's probably some exotic examples that are really difficult, but derivatives, like, there might be a lot of algebra, but you should never be stuck. Integration, those can get crazily complicated. And if they're not from a direct formula, it's probably a competition question or something. So it's a little bit hard to answer that. Like, maybe you need to use a power series, but that's a little bit too big of a question. Like, I don't know how to answer it, really. To say I'm going to share something controversial, Arrow's law is the closest thing to understanding democracy because of all the other ethics systems would still require those 5 conditions in some form. I thought that you didn't like the conditions for Arrow's law. I don't remember. Maybe I'm misremembering. Hey, FA. uh, well, you know, I love just making crap up, so I was just kind of making some random markings and pretending like I know what I'm talking about. Sounds like a conditional acceptance in a way. Okay, that's good. Chasu. Integrals are always continuous. Uh, oh yeah, you can have derivatives that like introduce discontinuity is what you're talking about. Yeah, you could integrate, I guess, like a discontinuous function and get a discontinuous result. You like using the limit definition for a derivative? Like what function are you trying to prove it with? Because usually you only use the limit definition to prove it for basic functions. And then from there you can use things like chain rule and product rule for more complicated functions. What was the conditions for Arrow's theorem? Lies. If you talking about what Syntax said, he corrected himself. Like because it was disproven by himself and he was awarded the Nobel Prize in economics. He's sure that if you gave the most freedom to the voter would be a dictator based off one voter being pivotal to societal change. Yeah, it's like the Wikipedia page is calling it the non-dictatorship. If you gave the most freedom to the voter, I mean, isn't that, wouldn't one voter only be the pivotal one if they're split nearly 50-50? Yeah, Z Hurricane, I see. I was just trying to figure out suck now. The thing I have with that is like it's such an edge case. Like I feel like you shouldn't have to throw out the entire thing because of a few edge cases. So Zerkane is asking not necessarily for the actual answer to this question, but just kind of like the general strategy for this type of question. And this is just painful. I think this is a bad question, to be honest, that shouldn't be asked. The conventional way to do this is to the brute force way of doing this is to plug in p of 45 to the minus 100, check if it's positive or negative. I mean, it could be equal to 0, but then you'll be done. And then plug in 46. And then it needs to have the opposite sign. They could be really mean and give one with the same sign. But the idea is that you would want to show that the polynomial is sometimes negative and sometimes positive on this interval. And because polynomials are continuous, that means there must be a zero. They're being intentionally stupid here with giving huge numbers for no reason. They could be doubly mean and like have given, if the polynomial looks like this, they could give you like a positive number here and a positive number here. And you would have to figure out that there could still be a root there, but you have to guess and check for what a negative value of the function is. And so theoretically, you can choose any other numbers to plug in between these two numbers that might be more convenient. For this one in particular, I have no idea how you would simplify the work, though. This is just a terrible... I think this is just a bad problem that doesn't teach you anything, to be honest. Binary search until two signs are opposite. I mean, theoretically, yeah. I don't think that's going to help the calculations, though. Press some trick to avoid the test or approximate the test? Probably. I assume they... Unless you have a calculator, I assume they don't expect you to actually work out the sign of this stuff. Maybe 51 goes into 23. It does seem like there's a similarity there. So maybe you can, without calculating it, you can figure out the sign of this, potentially. I looked, hard luck. Thank you so much. I know, I just kind of like, that one like grabbed my eye. I'm a looker. Yep, a looker and a hooker. Ah, I didn't mean to do that. No, 51 does not go into 23. If it did, you can try to get a comparison going. Power 45 is too big. Just assume any number. In between is real. In reals. I mean, this is a really small number. This is nearly 0. Yeah. So honestly, with the 45 to the minus 100, that might not be the worst thing to actually figure out because the powers are going to simplify. And like these two terms here are going to, maybe the 1035 matters. I wanted to say that these two terms here don't matter because the degree of the others are so much bigger. This is such a small number that it might be the opposite though. Like, or like the constant term might matter a lot. The minus 45x I don't think matters. So this is something you could maybe guesstimate the sign for. You don't have to actually get the number, just need to figure out the sign. I agree if you had 100 people, 50% changes society's political system, yeah, it'd be considered a dictatorship. I like to include a factor into Ariel's argument. What if each voter decides to become a candidate? Ooh, I mean, that's even crazier. And even that's only a dictatorship for that one choice. It's not a dictatorship can make it, like, it's not a dictatorship in the normal sense of the word. maybe for that one vote, that one voter gets to act as a dictator, but every other vote isn't going to be that close. Yeah, I can give a simple explanation for Rolle's theorem. Let me just make sure I get the statement for Rolle's theorem correct. Okay, so Rolle's theorem talks about critical points of a function. So that might be able to be an open interval. Okay, wait. Okay. Instead of doing this, let's not rewrite it. Let's just take this bit from Wikipedia. Okay, so this is the actual statement of Rolle's theorem, and what this means is that we're given a function f that's continuous on AB closed, differentiable on the open interval, which isn't, don't read too much into one being open and one being closed. It's just how it's written. There's a reason for it, but it's not super important for just like learning what this is saying. So you need a function that's continuous and differentiable, and at either end of that interval, the function equals itself. So this is x equals a, this is x equals b, and we'll say that at a and b have to be at the same level. And so now the game is connect these two dots without ever lifting up your pen or pencil. You're also, it has to be differentiable, so you can't do a corner. What Rolle's theorem says is that no matter what way you choose to connect these 2 points, as long as it's continuous and differentiable, there must be at least one place where there's a critical point. So like here and here is actually 2 critical points with this path. This would be an example of one with just one critical point up there. And there's a special case. If you just have a flat line, you consider every point on here a critical point because the slope is always 0. That's basically the idea of Rolle's theorem, though. There's no way you can connect those 2 dots without introducing critical points somewhere. Just revises that term because I think it doesn't give total freedom to the voters then. I mean, if that's just where the chips fall, I think that is freedom. I mean, like, how would you decide who the 51st voter is if they all cast their vote at the same time? Maybe you could argue if that 51st voter somehow knew what everyone else's votes were, then they could be a dictator, but they don't have that information usually. No worries, Z Hurricane. I've always wanted to study the Rolls-Royce theorem, but you can't afford it, Fizzbuzz. Same. The transitive nature only works on an ordinal system of 3 candidates. Doesn't talk much about it from the sense of the 100 voters are candidates, and these 100 voters would vote for themselves. Yeah, so I feel like to be a dictator, or to be a dictator in that sense, you'd have to know how everyone else is voting, but that's not usually the case. Well, when you're in the voting booth, you don't have that information, I guess. Have you guys heard that sometimes, especially physicists note dx before the integrand? Yeah, that's pretty common. This is urgent as you're in an online argument. I have it on my hard drive here. I was just that the general relativity book that I was using did that. Oh, where is it? Here we go. DT. This is Gravity by James Hartle. Oh, you know, I probably still have the link to the download pinned in that Discord chat. It's available for free on archive.org. Book page 62. Hey Aditya, what's the question? So annoying. So go forth and be annoying. So quiet, so pensive. Yeah, Jen. I had to mix up the music. I do like the synthwave stuff, but I don't know. Today was a piano kind of day. C's QFT book also does this. Becomes very clear that notation is useful. Really? Because I didn't find it very useful, at least in the relativity context. Oh, I see. You posted it to the Discord. Oh, nice. Yeah. Okay, so for differentiability, the two things to watch out for are jumps. So if the function does that sort of thing, it's not differentiable right there. The other thing to watch out for are what you might call corners. So if the function does that, it's not differentiable right there. So those are the two like only tricks to look out for with these. And so with this one, oh, there's another trick. I mean, it's a little bit annoying. So right here we definitely have a jump. So x equals 0 is certainly an option, and this is a pretty crappily made multiple choice question. because that automatically means the answer is A. The reason x equals 2 is also non-differentiable is because think about the slope of the tangent line. That's what the derivative is. Right at x equals 2, the slope goes exactly vertical. That's considered not differentiable because it's like an infinite slope. Like a horizontal line is slope 0. A diagonal line like that is slope 1. And if you keep increasing until you're exactly vertical, it's infinite slope, but we don't really allow infinity. How the derivative would look at that point is the derivative would be something like, you know, ... over x minus 2, maybe, or maybe squared or something. But it's like the derivative has an asymptote at x equals 2 is the point. So it's kind of cheesy, like, I don't know, it's not what I normally think of with functions not being differentiable, because there's still a physically meaningful thing that's happening there. Whereas in these two examples I pointed out, there's no meaningful derivative to take there. There still is some meaning with this infinite slope case. It's just, we say it's not differentiable for kind of like the mathematical purposes. How did humans invent O? Like, I assume you got cut off there. You're not asking how we invented the letter O. I assume some caveman did somewhere. Oh, how do humans invent all this from dirt? Well, it wasn't from dirt. They built on the shoulders of the people, but before him, I guess. There's always some geniuses who pushed it way farther forward, though. I saw a post where someone had written an integral like that. Someone was trying to be quirky about it. Oh, okay. I agree with the statement, but I was trying to challenge it from his conditions using other ethical philosophies or perspectives in philosophy. I still come up empty because accessibility under each ideology would still be necessary, even if I believed in a terrible ideology like technocracy. That includes some sort of voting system, but the technocratically approved voter would still require the conditions laid out by Arrow's theorem. Yeah, I guess you're right that voting can happen in things that aren't democracy specifically. Even then, I personally wouldn't be very sold on like a toy example with just 100 voters. But I guess with something like you're saying, like a technocracy, maybe that could happen if they only let a small number of people vote. I guess, I know, I think there's still like, yeah, I guess I can see why you might be going that way. Become a king of the USA, make food and water free, and no study. All right, indeed, you will do. Sounds good. Sleep well. SB, yes, I was. I'm doing a bonus stream today because I won't be able to stream at my normal time tomorrow. So, I mean, I won't be streaming math at all tomorrow because I have plans at my normal stream time. On Twitch, I might play some video games in the evening, but There won't be a math stream tomorrow. No, I don't really watch anime, no. Your philosophy is maximizing sunshine and lollipops. Oh yeah, yeah, I know suck now. Um Hey Armand, welcome back. So the thing that you're considering is if you have all 100 voters also being candidates. I mean, if they all just like voted for themselves though, then you'd be in like a 100-way tie, right? But maybe you're not going that direction with it. Chemistry? No. I thought I would like chemistry until I took a class in it. There might still be some aspect of chemistry that I might like, but that's something where I have a hard time prioritizing actually studying it. Armand, I've tried JE problems before. I just generally can't do them. Chemistry is fantastic. It's a lot of memorization. I don't know. Preparing for an exam doesn't feel good, but as a subject, I do think it's good. Fair enough, SB, yeah. I'm trying to do this integral with complex numbers because I'm trying to learn complex analysis. And so I've drawn this contour here, and the thing I'm trying to figure out is how to evaluate the integral along the contours up here. C4 and C5. If I can do that, I think I have the problem basically solved. Is this like a problem inside of a problem, I wonder? Because I think this thing with a U sub isn't helpful as far as I can tell. And I might want to return to thinking about this. I forget what the bottom factored into. Ugh. Okay, yeah, I did that. And then I put the x out front, got rid of the squared, got rid of that x. We could take his transitive part of his theorem, maximize it with a voter being a candidate as well. I think it would show a huger light on entire freedom of the voter. Seeing all the conditions, adding the sixth condition, all voters can be candidates. The transitive part of his theorem. Which one is the transitive part? But is that like a formal thing here? Like by Control F transitive? Oh, there we go. Oh, okay, yeah, sure, sure. Tim original, Timo original. Thank you for the follow. So, with what you're saying, Saknel, would you want every voter to rank all 100 candidates? Is that your idea here? So the thing that I don't want to do here, but I think might be necessary, is to partial fractions this. You know what they say, the hardest choices require the strongest wills. But even if I did do that, how am I integrating sine x over x? That seems like a pain. That needs another complex integral, to be honest. Or something. Person to rank themselves if they themselves were a candidate. But like, will rank themselves against all the other 99 people. Like, they're ranking all 100 people, including themselves. And it's kind of interesting, but what I assume a tie is still possible. It's just more complicated. Or do you not mind the part with being tied? You don't mind it being tied? Okay. Shine a huger light on the freedom of the voter. So then, maybe you explained this earlier and need to revisit. But so then how would that like make people more free, I guess? Like, is it avoiding the situation you said with the 51st person like kind of acting as a dictator? Like, you know, avoiding a pivotal voter situation? Yeah, Armand, that's the problem that I'm working on. I'm kind of stuck on this part. I'm not sure what quite, like, what exactly to do with these two contours. It would avoid it, but it gives another contradiction you want to expose. Okay. Interesting. Um, this is kind of annoying because why is it annoying? Like I say, I just don't know what to do with this integral. If I magically just said that it cancels, would I get the answer that they say here? Like, that could be an indication that I should be trying to justify that it's 0. Theoretically, if these two integrals did cancel magically, how would I proceed? What is... I'm gonna go to Wolfram Alpha. What is the thing that I said I got for C epsilon 2? Minus I pi over 2 times sine of I. That nearly looks like something. What in the answer, pi over 2, 1 minus 1 over e. .9929. Really? 923. Okay, so I am... There's an extra little bit. I think the integral should not be 0 then. Because otherwise these two things should be the same. This is 0.92 and that's 0.99. I mean, not specifically the residue theorem, because I'm not enclosing a singularity, but I have calculated the integral around a half circle arc around 0 and I. The one around 0 gives me 0. The one around I gives me minus a half sine of I for the residue. Like, if I just gave this integral to Wolfram Alpha, what would it do with it? I'm going to give it as an indefinite integral 2 just to be The guy blocked you for it? Nice. That means you win. Dude, why does Wolfram Alpha never remember my choice here? X plus I. Okay, Wolfram Alpha is not a fan of that. It does not like what I'm doing. You're good, Armand. Um, where do they use this contour? Oh yeah, that thought did occur to me. Should I be replacing the sine of z with an e to the iz? Is that what I'm doing wrong? I think it is. Maybe that's why I'm struggling with this. Okay, so I should be maybe that'll give me something to work with. Instead of sine of z, I should be thinking about e to the iz. And actually, that's going to change these up here, isn't it? Yeah, Armand, that they give us that as part of the problem. Uh, also gives me the mathematical proof that the system also proves how a reformist anarchic system of the total freedom of the individual doesn't work mathematically speaking because of the contradictions between each condition within democratic anarchism. Hmm. Can also gives me mathematical proof. I guess so. With a non-dictatorship that we were talking about. Hey, mouse. Um, is e to the iz, does that, do I still have my, is this still an even function when I replace sine with e? Wait, is this from 4.3 or 4.4? This problem. We're all the way down. It is from 4.3. Okay. Write down that gives you a larger picture. Okay, fair enough. Um, what am I looking for? Oh yeah, I'm just looking for an example of maybe I feel like I don't get the symmetry with E. Maybe that's okay. I don't know. E to the IAX over X. Well, can we just cite this result? Because actually we're getting this as a sub problem in our problem, I think. We need partial fractions, which is very annoying. Actually, we're not really getting it as a sub problem. Oh, oops, this is minus r plus iy. Uh, damn it, why is this so hard? Yeah, let's go back and calculate the residues at least. like for this first one. That's not so bad. So the residue for epsilon 1, we get e to the 0 over the derivative of the bottom, 3z squared plus z, or plus 1. 3z squared plus 1 is the derivative. We plug in 0. So we just get 1. And then for the singularity at I, we get e to the minus 1 over minus 3 plus 1, which is minus a half e to the minus 1. We should have say 1 over 2e. So that's actually really and then what's our formula? So it's I pi times, okay, so this one gives us I pi. This one gives us I pi minus I pi over 2e. It's looking mighty similar to the answer. Not quite, but it's getting there. Hmm. Is it, we got rid of the sign of I stuff, which was definitely, I think that was just like 100% wrong. Am I winning? No. This is the second stream that I've spent on this problem. I spotted one mistake that I was making. Is significant. But I'm still kind of struggling with it. Hmm. I've seen these very annoying integrals like e to the ix over x, which I'm really not a fan of. Call me crazy. How are they doing it? How are they doing this integral right here, I guess, in the example? That's one that I should be looking at. Oh wait, I need to mind my signs, don't I? So wait, this integral is going the proper direction. This integral needs to get reversed. Like I need to flip its sign, don't I? That might end up being bad. Let me just question mark that for now, so hopefully I remember to go back and think about it later. The book used it in this example here. It's just with the locations of the singularities. I kind of assumed that would be the right contour to choose. Maybe not, though. The problem itself didn't suggest a particular contour, but yeah. Ooh, Joseph, congrats on the first. An hour and a half into the stream. Today and yesterday, people were pretty lax with it. I think yesterday was like 3 hours into the stream. Someone got it. Or like maybe 2. I don't remember. Hey, Malik, can I suggest any math topics for a programming project? Well, there's just so many different angles you could do with that. I have a hard time suggesting one in general, but like differential equations has a lot of projects like that. Number theory has a lot of projects like that. Numerical methods is kind of like the dedicated part of math that you tend to use coding for all the time. If you just kind of want a general thing to look through, Project Euler is a pretty cool site. They give math-based coding problems, and you can submit your answer, and then once you've gotten it right, you can see how other people did it. But like, yeah, so I got signed out for some reason, but if you're signed in, you get a little box where you can submit your answer. But yeah, if you don't like the idea of the site, then I just find a textbook and just look through the chapters for the problems that they suggest. If you're not sure where to find a textbook, let me actually link you to a really good site. This website has a bunch of actual like college textbooks that are free and legal to use. And so they have a bunch of them on math. So you can just find a textbook for a subject you like, and there will almost certainly be coding problems somewhere in there. Oops. One project you liked was when you were in high school implementing error correction codes. Ooh. Aiming code? No worries, Malik. So this is like for like input errors? Computer science and telecommunications. Oh, so maybe it's like if there's a hardware error. Noisy communication. Okay, okay. That makes sense. That is a cool thing to like think about. I like that. Hey Thunder, be math question I can solve on a non-factorial stream. One day, yes. Hey Phobos, hope you're doing well. I remember you actually did help me out with, so it's just like some physics ones that someone asked a while ago. Um, but yeah, if it's just things that I'm studying, I have a bit of a head start on you for like the things that I've studied in math. So yeah, this integral that I've been working on, I wouldn't expect you to be able to do that. Any digital data uses some kind of error correcting codes. That's awesome. it's it's a terrible integral, Thunder. I'm trying to solve it using complex numbers. It's probably also possible to use something called Feynman's trick. But I'm trying to learn about complex analysis. And so this is the integral I've been breaking my brain over for 2 days now. But yeah, it's actually a really cool like technique where the integral that we're given is only about real numbers. But if you're clever and you can find a path in the complex plane, like as is that fat type shit 90 or FST type shit? I don't know if the S is like a substitute for A. I don't know. Either way, thank you for the follow. Basically, like as long as a part of the path reflects the actual integral that you're interested in. So I am doing the integral along like the real axis. You can use a bunch of complex variable techniques to actually to get the result for the integral without having to actually integrate this. It's still not easy. Oops, sorry if that made a weird noise in my mic. But it's a really cool thing if you can actually figure it out. So far, I can only do very basic ones. Okay, so what I was thinking about was, can I just cite a result from the book? Or I'm trying to understand this example. And I think what they're doing is they're evaluating these second two integrals here. They're saying this integral gets you 0. They're saying this integral gets you minus I pi. And they're subtracting, or they're adding the, they're putting that result onto the other side of the equation because we know it should all equal 0. So they have the sum of these two integrals is equal to I pi. And then they say, well, these two integrals, if you use Euler's identity, are really just cosine plus I sine. And if you take the limits as epsilon goes to 0 and r goes to infinity. So I think what needs to happen is These two integrals, I can do that exact thing on. These two integrals, I need to manipulate. Probably. These two integrals, I want to say they cancel. I really want to say they just cancel. I don't know if they actually do. Cancel the whole question, say the answer is pi. And that's not far off. They do give us the answer is that. So you're at least like, you've gotten 1 out of 6 components right or whatever. Or 5, I don't know. Yeah, these are my vertical ones. And so the initial idea was that they should cancel because the original thing is an even function and they have opposite orientations. But as soon as I replace the sign with E, I don't know if that still holds true. So that's why I'm unsure about that. Thanks for the lurk. Shouldn't there be a... no, never mind. Maybe I should write a second line here. So these two circular arc integrals, so this entire thing is equal to 0. You believe the numerator is bounded. I don't see why. Oh, wait, this numerator? Ooh, you want to try and make them 0? Something like gamma of t equals r plus it? Basically, yeah. Yeah, it's like that path right there. And so the idea is that r will go to infinity. Only t controls the modulus? Okay. Yeah. E to the IR, e to the minus t, yes. And the most that can be is when t equals 0. T goes from 0 to 1, which is clearly bounded by some constant m that doesn't depend on r. Oh. We don't need to know exactly, we can just apply the extreme value theorem to get that m exists. Oh. So number behaves like r cubed, right? Hmm. It behaves like m over r cubed. And since we're letting r go to infinity, we're just going to get 0. Hmm. Okay. That's nice. Just gonna. I think I understand the gist. I don't know if I'd be able to actually argue that in full. Probably won't put the absolute value. Oh, yeah. Especially on like how exactly you'd apply the extreme value theorem, I'm not quite clear on, but I can imagine that you could. That'd be the function that you do the extreme value theorem on. But I guess you're doing it for y between 0 and 1. Okay, you know what? I can't remember what the extreme value theorem even says exactly now. Let me just look at it. I know it's about proving that extreme points exist. I don't remember the conditions. Okay, yeah. That's right. Okay, okay. Hey Jonathan. Uh, this program is called Journal Plus Plus. Me thinking about it, this phenomenon of being a voter, being a candidate, fascinates me because you have a Condorcet loop with that particular individual. I have not heard of that. All right. Well, thank you for the hint there, color cone. I appreciate it. Google doesn't know what this means either. Good luck with whatever you're doing next. Yeah, sure. Links are turned on in chat, so you can just post them. Um, okay, and then those. Condorcet. The majority rule is inherently self-contradictory. Ooh. The result implies that it is logically impossible for any voting system to guarantee that a winner will have support from a majority of voters. Simply mean rock, paper, scissors scenarios where majority of voters prefer A to B, B to C, also C to A, then even if every voter's individual preferences are rational and avoid self-contradiction. This feels very similar to Arrow's theorem. You have a Condorcet loop with that particular individual. But then what does Arrow's theorem say that's different? Oh, okay. Arrow's theorem is essentially more general. Pi's methods of making decisions other than one person, one vote elections, such as markets are weighted votings based on ranked ballots. Hmm. Uh, yeah, Jonathan. The theme of the stream is I answer people's homework questions, and right now I'm talking to Sakano about a thing that he's interested in with like voting theory. It's not something that I normally like talk about, but I don't mind it. Um, if there's like a homework question from chat, I choose something to study, and so I'm trying to learn complex analysis, and so I'm working on solving the integral at the top of the page using complex variables. But yeah, if someone does pop in with a homework question, I pretty much immediately switch gears. I need to see it again. What was the denominator? I keep deleting. Okay. Error tried to say that ranked choice voting was going to fundamentally alter the outcome, then later found that ranked choice voting also has a major flaw. Okay. I remember the first time we talked about this, I think Jed brought up CGP Gray's voting series, and he didn't really talk about the stuff that you're talking about Sock now, but I remember he did argue that like ranked choice voting does fix like the spoiler effect of people having to like strategically vote, but there's a lot of things that it doesn't fix, like tending towards two-party systems and stuff like that. But I think Arrow's theorem was a lot more like theoretical with the contradictions that it finds. Yeah, Jonathan's like just earlier someone asked me to explain like dot products and cross products for vectors, so I did that. Uh, that one was a weird question, but I explained what Rolle's theorem is. Then someone posted this question about where this function is not differentiable. So yeah, it's kind of whatever people want to ask about. Um, my knowledge only goes like so far, but yeah. What's up, Mouse? These two integrals are what I'm trying to figure out, like, what to do. Yeah. What is it, mouse? Because the denominators just don't match, and that's kind of a non-starter. Should I think about, like, should I go back to thinking about the U sub? The issue with that is that it introduces complex numbers into the bounds. And I don't like that. The idea that mathematics can be shown to have the 51st percent of 100 voters to alter society's choice ends up like a person knowing how to scheme a lottery ticket. And the spoiler effect argument from that other person is weak. I mean, I feel like I can find the actual, like, series. He explains it in, like, he was not at all thinking about the things that you're thinking about. Like, he was trying to just, like, communicate different systems of voting to just, like, regular people, not getting into the philosophy of it. I ended up watching the entire series. Insider voting can happen using this former knowledge. I don't know if I really buy that, to be honest. Is it the alternative vote one? I don't remember. It's one. I don't remember. It's like one of those, but I think it does avoid the spoiler effect. Like, two people from the same party both running wouldn't step on each other. And Jonathan, I saw you post a message and then retract it. If you have a question for you to let me know. Yeah, no, it's talking about what I think isn't that, like, relevant to what you're talking about. I just thought it was, like, an interesting series. We have two complex numbers. Oh, this is a different. Okay, it's a similar question to what we did the other day, but not the same. I assume determine the equation of this line, and these conditions define that line. But in typical them fashion, we have to just do some random calculations with complex numbers first, because we can't just make life simple. Okay. We have to simplify this thing here. Let's look at the real parts. 3. I to the 6 is like I to the 2, which is -1. So 3 minus 1 is 2. Where's my cursor? Hello? Oh, there. So we have 2 plus 6 is 8. The imaginary parts, 4 minus 8 is minus 4. Uh, 3 minus 4 is minus 1. 4 minus 6 is minus 2. Now let's rationalize. Oh. No worries. I was asking so the question is like, these conditions define a line. They're asking us to get the equation of the line, mouse. If we do minus 8 plus 16i plus 4i plus 8. One plus 2. Plus 4. It does avoid in a discrete sense. I don't find it avoids in a social sense. Like if someone knew that they were the last person to vote, like let's say polls close at 3 p.m. in the country, they decide to vote 10 minutes before, they would be that person to alter their selection. I mean, that's always going to be rough though. Like they're never going to be able to do that exactly. Like, yeah, sure, maybe you can overhear how people are talking after they cast their vote, but it just doesn't seem very realistic to me. Okay, so I'm getting that W is 4i. Okay, I'm not hearing back from you, Mouse, on what the question actually is. I'm going to put into Google Translate. So I want to make sure I'm doing this right. Or I'm answering the right question. Ah, come on. One minute. Defines a line. Determine the length of the line. Okay, that's different. I thought they're going to ask for the equation. I mean, okay, like just using American as an example, though, suck. Now, America's way too big. Like, someone in California can't figure out how the people in New York are voting. It's not easily, and adjust their vote accordingly. Like, I guess it's easier with social media, but like, that's not really representative of how people actually vote. So in the complex plane, the mod of z equals the mod of w, and the imaginary part of z is greater than 0, and the imaginary part of z is greater than 0 defines... That does not define... that. I mean, I guess it's not a straight line. So, oops. So I'm getting the mod of W is equal to 4, right? Because I found the W is just 4i. So, well, this condition defines a circle. If the mod of Z is equal to 4, it's a circle of radius 4. And it's only this quarter of the circle because of the second two conditions. And so I guess we could still call this a line. It's not, I was expecting a straight line, but sure. And so the question is really, find the circumference of a circle of radius 4 and then cut it in a quarter. So it's 1/4 times 2 pi r, which is 4. So just 2 pi, I think is the answer. Maybe it's a geodesic. True, Femvox. Yeah, what is this curved complex space? Complex space. So that has to exist, right? Well, no, I guess it probably couldn't. Like, is there a non-Euclidean complex number? I feel like by like that, there's no way that would be a helpful thing. Oh wait. Wait. What? Oh no. Ah. I keep doing that. So this is the Wikipedia page for non-Euclidean geometry. All right, good night, Mouse. Thank you for the question. Oh. Huh. Weird. I don't quite understand what this is doing. I've seen this idea before with having like a complex number, but the thing you're squaring is equal to +1, which is really confusing, but possible to define. Was a circuits problem slims Discord. He solved it on stream, got 100%. Wow. They are, yeah. I feel like Dr. Cook talked to us about this at some point. Daniel, yeah. he did stop just showing up. Maybe we would have gotten farther. I don't know. Oh, Clifford. Are you the Clifford of Clifford algebra fame? That's another thing that Dr. Cook, I remember he was streaming about that for the few streams that he's done. Find a new girlfriend. Oh, yeah, you know, that's true. I'm also just like joking. He of course doesn't owe us squat, so Okay, this is the Clifford algebra, dude. I wonder if that's how Cook knows about these. Oh, that's what make. I thought epsilon is just 0 in this, but epsilon is. It's a number that is not 0 that squares to 0. Okay, that makes more sense for why this isn't stupid. Using to represent the dual angle, which represents measures the relative position of two skew lines in space. That's cool. Um, hey, Lucky. No worries, Sock. No. But yeah, Thomas, I'm still beating my head against this integral here. I didn't realize I was making a mistake. I forgot to replace sine with e to the iz. And then color cone gave me a hint, or, well, basically solved a piece of the problem, which were these two sides of the razor blade, showing that you can bound them and show that they go to 0. But now I'm struggling with the upper flat part. That's the last part that I haven't figured out yet. Oh, no, I still need to work on branch cuts more, but I wanted to mix it up and go to integrals. I feel like with branch cuts, I made a good amount of progress in understanding the basics of them. I'm still confused about how you analyze it for harder functions like arc cosine. But for things like roots and logs, I feel like I know those decently well now. I want the contour to enclose I. Oh, really, Bluebird? Uh, what will that do for us? Oh, maybe that would be easier to evaluate. Just do a semicircle and just deal with enclosing I. Because the result of that... Like, we could do a residue for the right-hand side. Okay, yeah, let's think about that. Uh, yeah, I guess let's just do an infinite semicircle. Yeah, we'll have to deal with the circular arc, but maybe that'll be easier. Okay, so then indent oriented like so. So we'll say this one is C epsilon, this one is CR, and then C1 and C2 because I'm uncreative. Okay, so we are enclosing one singularity. It's a simple pull. And so the function, we're going to magically make that sign into an E. By Cauchy residue theorem, that should be 2 pi I times the residue. The residue, we can do e to the I times I over the derivative of the denominator with I plugged in. 3 times minus 1 plus 1. Which is, drumroll please, minus 1 over 2e. So after the dust settles, we get pi I over e, the minus. Okay. Not a bad start. That looks like part of the answer right there. But we know that is also equal to the sum of these integrals added up, or the sum of the bits of the contour added up. So we need to deal with CR. For z squared plus 1 dz. Yeah, I wonder if the razor blade just isn't a good idea. Or it's only a good idea with certain ones, I guess. I don't know. It seems like you just have to do a bunch of these integrals before you can have good intuition for this. For like what integrals work or don't work. Now the deal with C1 is it goes from minus R up to minus epsilon. E to the ix over x squared plus 1 dx. C2 goes from epsilon to r, e to the ix over x squared plus 1 dx. Book if you used recently has a theorem for the form sine of x times f of x, where f could be something like a rational function. Oh, it's a rectangle? Side lengths get infinitely large. Really? I thought this book does a similar thing for sine of x times a rational function. Does it? That feels familiar now that you say that. Okay, yeah, this is for sine of x times a rational function. Do I see a figure with a... That's a semicircle. I'm kind of intrigued by the semicircle thing. Like, I want to see if I can make that work now, but the infinite rectangle is interesting too. Slim, thank you for the raid. I hope your stream was good. Oops, I keep bumping my mic. Welcome in, everyone. Right now, you caught me. I'm still working on the same contour integral I was working on yesterday. Trying a new approach with a different contour. Yeah. Thank you so much for the raid. Yeah, so I normally don't, or on Fridays I normally play games, but tomorrow I can't stream at my normal time, so I figured I'll just do my math stream today at my normal time, and then tomorrow I may or may not stream games. Oh yeah, I I did hear that you passed Fenlux's circuit quiz. How's life after relativity? I feel scarred. I don't know. The causes of what I learned are really fun, and I like those with like Lorentz contractions and stuff like that. But I'm very happy that I don't have to do more differential geometry. Just one question. More surprisingly, I was able to construct a pentagon with a straight edge and a compass. Ooh, that doesn't sound easy. Yeah, I would probably use like a million steps if I tried to do that. Um, oh, you sent me the image of what you did. It's a lot of circles. What the hell? You want to print it to put on your fridge? It is like... It does look a little artsy, yeah. Or unless you just mean like you're proud of Slim and you're giving him a gold star like yours dad. The 17 gone true. How to draw an equilateral triangle. I would oh my god. I would start with probably two circles where like this is the center of the circle that's also on the other circle. This is the center of the other circle and that intersects the other circle. That feels like a good start. I feel like we need a third circle. Maybe one down here at the intersection. And do we draw it out to the other intersection? That won't be equilateral though, I don't think. Will it? I don't... They will be? Oh, okay. But yeah, this circle I think is bigger, or it's not the same as the others, but maybe that's okay. Yeah, I don't quite understand why it would be, but that's... You don't need it? Oh. Oh yeah, okay, true. You just need to mark the point. Okay, yeah, no, I see why that's equilateral now. Okay. There you go. Wait. Is a pentagon a square plus an equilateral triangle? No way, right? I doubt it. No. I did draw a nice house. That's very true. Professor Eisenbud attempted to draw a 17 gon on number file. Oh no. A pentagon, but not a regular one. Okay, yeah, fair. So 0 is a simple pole, so I can use the one theorem. I need to space these out. No, I don't want the epsilon. Okay, so C epsilon, that bit, it's going clockwise, so we need to stick a negative sign on anything we get. It's going to be pi, the angle that it goes through, times I, times the residue at 0. The residue at 0 is e to the 0 over 3 times 0 plus 1, which is just 1. Okay, so minus pi I. This one, I need to look up the theorem in the book for when the arc is infinitely big. It might be in 4.2. Himanshu, I'm using a Huion tablet. It's just a cheap one that I bought off Amazon. It gets the job done. As r goes to infinity, does z f of z approach 0 uniformly as r goes to infinity? Let's think about that. This. So we're curious to justify that e to the iz over z squared plus 1 goes to 0 as r goes to infinity. My iPad? Or it's not like an iPad, but it's just like a writing tablet, if that's what you mean. I feel like you're making a joke that I'm not understanding. I don't know. R squared e to the 2I theta plus 1. What are you? What are you? Well, I guess we want cosine and I sine. Maybe. So we're gonna get e to the minus r sine theta. E to the IR cosine theta. R squared e to the 2I theta plus 1. Okay. From here, can I be hand wavy and say this bit approaches 0? This bit just rotates us around and doesn't affect anything. This bit down here goes to 0. Or it goes to infinity, but it's being divided out, so it goes to 0. So 0? Which means I'm justified in saying this bit is 0. And this might actually be it. What if sine theta is negative? Damn it, Fenvox. Will this bit save it? I mean, the theorem as they present it is just for a general function f of z, I think. So I might be not applying the theorem right. That's always possible. Or I might be using the wrong theorem in the first place. And I should look for a different one. But in theory, if I can justify that if zf of z goes uniformly, then it would apply, but I mean, I was hoping that it's e to the iz, and I was hoping that the I would save it. Otherwise, I'd agree. Maybe that's why the rectangular contour comes in. Let me just quickly scroll through 4.2. I just knocked my pen over. Because they did introduce this theorem for integrals with branch points. And we don't have branch points. So maybe I shouldn't be using that. Complex. So I don't think there's going to be any quals for my degree as far I haven't heard of any, at least. I've already signed up for the more difficult complex analysis class. That is the reason that I'm studying this, and they just let me register for it. So I think I'm just in. And as long as I pass the class, I don't have to do anything extra. Oh, hey, look at that. This is way better, isn't it? It did say F, or I don't remember what I was looking at. So for second year courses, they literally don't care. Okay, so I assume we want Jordan's lemma, and that means we do get to ignore the e to the ikz bit. There's no way f is any function though, right? This would probably mean a rational function. With degree, the degree on the bottom is at least 2 more than the degree on top, probably. They're not really clear about that, I feel like. But maybe it's the same definition up here that they're using again. Or maybe it just matters that it can be uniformly approach 0. No, maybe it's not that. Maybe it's just anything that uniformly approaches 0. First sentence on that page. The first sentence on this page, like that one? I don't think that's what you mean. Or do you mean this page? I don't know. I'm saying that Jordan's lemma lets us say that's 0. Sue me, if not. That one was it? Okay. And I still don't know that's the same thing, but... Or that... I don't know. What's the idea, but in the proof of it? Let's find out. So that's the statement. This is the proof they provide. They use... I actually think Jordan's doesn't work because of the fact that sine theta depends on the angle. So I think it's going to work because it gets us the right answer. Or like, I think that integral equaling 0 is going to get the right answer. So something should work. You're saying sine theta depends on the angle. The thing that we're trying to prove uniformly approaches 0 is 1 over z squared plus 1. Fuck me. Ugh, I know exactly why that happens. And I keep doing it. It does mean independent of theta. So the idea would be to show that the choice of theta doesn't matter. That no matter what we choose, the limit is the same for theta. Hey BR Gaming, I'm good. How about you? And so if I took theta equal to 0, I would get 0. If I took theta equal to, well, I was going to say pi just to try to get something that's like negative, but that's a little bit unclear. No, I think it would be negative. Ryan Trahan 50 days. I have no clue what that is. No, I'm not watching it. So like just because there's a theta in this limit doesn't mean it can't uniformly approach 0. I think it is going to. The idea is to show that the choice of theta doesn't matter. I just don't remember how you prove this for a given function. Like, what would be the value of theta that makes this function have the greatest value? It's kind of hard to judge. So like this function, like z over z squared plus gamma squared, Jordan's lemma applies. I can't imagine that it wouldn't apply for our function. Uh, reading by the limit for a second. Actually, ugh, forget about all this for a second. 1 over r cubed e to the 3I theta plus r. Ooh, maybe I don't want to do it like that. Maybe I wanted to keep it factored. I'm pretty sure it does work if we just... If we can convince ourselves that the integral is 0, I think we do get the right answer from the mental math that I've tried to do ahead of time. But you've now got me interested in how do you actually prove this. So whether you like it or not, I'm gonna try and make this thing work. So I can name something. Wait, if I flip each side, I'm so bad at this. When things get flipped. This bound is not going the right way. I want something that is more than this. I found something that is less than that. Ugh. I hate the triangle inequality. It never does what I want it to do. I don't know. Fuck it. I'm saying it's 0. I'll put a question mark there. If I were to just push through and do the rest of the problem, then we know the entire integral is equal to minus pi I over e. From that bit, I'm going to do plus pi I. And then on the right side, we still have those integrals, which if we do the limit as r goes to infinity, epsilon goes to 0, combine them into 1, and then use Euler's identity, we get integral from infinity to infinity cosine x over x squared plus 1 dx plus I minus infinity to infinity sine x over x squared plus 1 dx. So you equate the real with the real, the imaginary with the imaginary, and we're going to find the integral from minus infinity to infinity x squared plus 1 dx is equal to pi 1 minus 1 over e, but they were asking about from 0 to infinity, and it's an even function, so we divide it by 2. So it does get us the right answer. There should be some way somehow that you can apply Jordan's lemma. Jordan's ligma. Okay, so Lubert, thank you for the suggestion of questioning the contour. I guess Bob also questioned that, but I was still kind of fixed on, well, I guess it was Lubert and Fembox. This was a team effort. I'm curious about the infinite rectangle. So I wonder if the infinite rectangle would we just enclose all 3 of the singularities and just have our rectangle go like that off to infinity? Or would I do an indent and have that go off to infinity? I don't know. Hey, Xfret, how's it going? Xfret just the other night did a late night probability theory stream, And that's the first math stream I know of that Xshred has done, and I was excited to see it. So I don't know if you have any more planned, but it was cool to see. Okay, so we finally did this. Maybe the razor blade contour should be a last resort. I'm curious about the infinite rectangle thing. From the base rectangle to what? Oh, true. Yeah, I forgot. Yeah, true. So I just to really like beat this problem to death. Can we think about the infinite rectangle? Because I just really have not spent enough time on this problem. I want to spend even more time on this problem. Oh wait, and I was getting the oh my god. I was making the rectangle get infinitely tall. I was supposed to make it get infinitely wide. So a rectangle that completely encloses I, like that. I don't know how tall we want to make this. There might be a convenient choice. I want to know this problem better than my family members. I do. Use a positive x1, negative x2 on the real axis, and y on the imaginary axis. It will get infinitely tall. Really? We're making it get big in two directions. Okay. Bold strategy, Cotton. Let's see if it pays off. So from the work we did on the last problem, it's still equal to minus pi I over e, the entire contour. Not anymore? Oh, okay. Fair enough. I guess we should number these contours. C1, C2, C3, C4, C5, because why be creative? I should really just name them like Steve and Rick and stuff like that. The text, yeah, but I can imagine it'd be pretty time consuming. I feel like they're like, at some point, someone's going to make a really cool text adventure game that's going to get people's interest in them again. Like, that just feels like a thing that, I guess that's basically what visual novels are now, though, but with more visuals. Parameterizations aren't too tough to get. X1 plus IT as t runs from 0 to y. True, yeah. Try again with a different approach someday, fair enough. You've been doing a lot of math. Well, yeah, you're also starting on, or like back on a degree soon. Okay, so I want to parameterize C3 now. So C3, the y value is going to run from 0 to t to use Lubert's. Convention. E to the I x1, a constant, plus I t. Oops, sorry. I guess 0 to y. And then y is going to infinity, but not yet. Some low-bit horror game that has a text adventure game built into it. Oh, that's pretty cool. Okay, and then C4, the most explosive part of the contour, runs from x1 to x2, e to the I, t plus iy? Yeah. T plus iy, t plus iy squared plus 1, dt. And then I just need to do C5. I might need even more room. It's so nice to be able to move stuff around, because if I was writing this in a notebook, I would just get close to the edge of the page and then start like curling down. And then I would realize that this is getting excessive, so I would start another line that also curls down right below it, and it would get really bad. I'm just trying to get my head around algebraic number theory, local fields, ramification theory at the moment. Oh, wow, Glorioso Tom. I definitely don't know anything about those. Good luck to you. That sounds very like sophisticated. Okay, so C5 runs from y down to 0, e to the I x2 plus it over x2 plus it x2 plus it squared plus 1 dt. Okay. What do we do with you? Well, the C epsilon integral, we've solved that like a million times. Minus pi I. Next, I think we employ the theorem that says the absolute value of each of those integrals is smaller than the maximum absolute value of the integrand times the length of the contour. Oh. But aren't the contours getting infinitely long? Maybe there'll be a cancellation. I should just trust the process. The ML thing. Yeah. The absolute value of each of the integrals is smaller than the maximum absolute value of the integrand. Okay, so we need to we're hanging on to these two integrals here. These are the three integrals we need to bound. We want them all to go to 0, really. So what's your maximum value? Tell me. x1 is a constant here. At least for now it is. Okay, maybe the maximum value, e to the I x1 minus t. I don't know if it's a good or a bad idea to multiply out the bottom. So this is the maximum value of the integral with respect to t. Or the like I'm trying to find the maximum value of this. What t can I plug in that gives me the maximum value? That's the question. I'm getting confused with the the x1s and the y's. In t equals 0 feels pretty tempting. Just looking at the e to the minus t in the numerator. I don't quite know how to justify that the denominator doesn't mess that up. Hey, Satvik. Hmm. Oh no, I don't want to do a partial. You think minus t squared would generate a higher magnitude than 2itx or it? Yeah. The length of the contour is going to be y. And y is going to infinity. Like, if we want ml to approach 0, we're gonna need our upper bound m to involve a 1 over y or something. I think. Hmm. I don't know. I think that the semicircle is easily my favorite way because this is not simple to me to try to bound these. Um. Well, yeah, I agree with that, Luberd. I don't know what to do with the denominator. That's what I've been. Should I be leaving the denominator alone? Am I overthinking this? Like, just say this statement? What would happen? So, if we multiply by the length of the contour, I'm confused here with the difference between t and y. Or I guess, like these, I need to do something with the t's in the denominator here, don't I? I need to say, yeah, I don't know what to do with the denominator, I guess. Because like the bound for e is pretty easy. Um, I don't know. I mean, I guess we could. Oops. We could say this. I don't know what to think about. It's easier for a more general case. If f of z is 1 over z, z squared plus 1, and this important property is that f of z is less than m over what's the value of z. Yeah, I'm trying to figure out why the rest of the denominator gets chopped off. Hmm. Um. Yeah, even then, going to infinity in two directions just feels very odd. Page 222. Looks like a similar situation, right? Okay, so this is the second time. So I'm not clear on... This is all addition here. Then you get subtraction here. Is this reverse triangle inequality? And the E can just be bounded by 1. The E is the easy part. I'm looking at this case specifically. E to the ix minus t. It's because it's minus t. Yeah. The other ones I'm not so sure of. Where all the JE kids are? I don't know, but I'm thankful they're not asking questions. E to the x blows up along the imaginary axis. Which contour? This contour goes with my C3. C3 is going to get infinitely far to the right and infinitely tall. It's not going to get close to the... It's not going to get anywhere close to I. Well, it is getting infinitely tall, I guess, but... Um... Just multiply it all out. This is stupid. I don't want to do this. I've already mostly done it, though. Partial fractions. I still don't know how to bound it, even if we did that. The theory behind that was grouping real and imaginary parts, but this is stupid. I don't want to do this. You know what? I think I'd rather just... I think I'm just going to move on from this question instead. I really don't get how you would bound this. Maybe it's possible. I just don't see it. The semicircle is love. It's life. I think that's just the best way of doing this problem. I was curious to see if this one would work. If it does work, it's way more complicated. You already... I don't know what I did, Puika. I definitely did not prove that all three of these integrals go to 0, like I would need to do. The vertical lines cancel and the top line goes to 0. Prove it. I agree they should. Prove it. That's what this entire thing has been about. um... Prove that this integral goes to 0. The exponential is the easy part to deal with. The denominator, I don't know how the hell you deal with that. And also, like, you need to do it for all three of these lines. Like, making an argument with evenness doesn't work if we replace the sign with exponential, as far as I know. Why I do math, not physics. I would rather not prove this, but I can't argue that they just go to 0 because it's convenient. Like, it's necessary to prove it for this question. I don't like doing proofs usually. It's way more than just e to the minus t. It's all that stuff. You can lower bound x plus it by absolute value of t, then upper bound it by 1 over t cubed or so. Well, I assume that's magnitude x plus it. Okay, if this doesn't work, then I just want to move on, but or probably end the stream, but what am I trying to do here? X is real, yeah. Or this supposed to be x1. I didn't. It's a real positive number that we're gonna make it go to infinity, but not yet. And x2 is gonna go to negative infinity. T can be small. Yeah, t is going from 0 to infinity. What we really want is more than or equal to x. Oh, okay. We're bounding this, we want to bound this thing above. So the numerator gets bounded above by 1. And we're saying right, you flip the inequality. So magnitude x1 squared plus 1. That's what I wanted to see. Okay. The other factor is trickier. Oh, or wait. For this here, or like these other two integrals there? That might work? Oh, okay. I don't see why not. Let's say hope. Okay. And then what am I doing with this? I'm taking this upper bound. If it's -1, you can't just put that it's mod x squared plus 1. Aren't we squaring it though? Or I don't understand. I guess I was just Hey buddy. Yeah, Peachy, the justification for the E part is you multiply the I in, and you can split it up by e to the I x1, e to the minus t. This is always, the magnitude of that is always 1. The magnitude of this, since t is positive or 0, this is at best 1 if t equals 0. Yeah, yeah. Hey Rudra. Is that a different version of the triangle inequality, Puika? Because if you just tell me triangle inequality, I would... It's the reverse one. Okay. Oh yeah, cubed. Oh, that's it. Okay. I don't know if I don't know if I found something else that's also valid, or if I just make that +1 to a -1 to match what Puika is saying. I'm just gonna make a match. Yeah, syntax. We've already successfully done it with a semicircle contour, and I'm a masochist who wants to do it a second way. So we're trying to do this infinite rectangle thing that Lubert is suggesting. That works in this case because we know the norm is a positive number. So I'm just gonna make it -1. I don't know, maybe it's not, I don't imagine that might not be important. Anyway, so seen the contour type before, can we finish multivariable calc? Yeah, you kind of need the multivariable calc, but it's really cool once you can use it. I could see you making some crazy ass contours. Okay, so the point of doing this is that we want to argue for this integral, it's bounded above by 1 over... I mean, we could make it x1 or x plus it. I don't know. In theoretical computer science, we just say it's big O of 1 over x cubed and call it a day. Yeah. That'd be nice. I know, I'm probably doing something slightly wrong with this, but the length of the contour is just y. Hey, Rouseb. So x1 and y are both going to infinity. Or like complexity analysis. I don't know, it's kind of weird that they're two different variables, but can we still just say that cubed on the bottom, power of 1 on the top, it's going to go to 0? And let x be about y? I guess if they're both going to infinity. Well, the thing I don't like about symmetry, Puika, is that as part of the setup for this problem, I replaced sine of x with e to the iz, and I don't think this is even anymore. Or at least I don't know if the argument still works. Plus, we just did. The integral we just did was for that vertical line there. Well, this is odd over odd. I don't know if this is. That was for horizontal? Oh, well, joke was on you. This integral I wrote in the middle is the horizontal one. That one's maybe a little bit trickier to bound with t, because that one, no, it's not. You want to make the argument that those two integrals cancel? Yeah, why wouldn't they cancel as long as x1 equals x2? And Lubert is trying to keep things more general. And wants to keep them separate and just prove they independently go to zero. Yeah. To be honest, I wouldn't know what's like theoretically better, but I mean, I guess it's like stronger if you can prove they independently go to zero and not just cancel. I think. Okay, if we wanted, so this one is actually for the horizontal line. Y is between 0 and infinity. So this can be bounded again by 1, the numerator. I think it's going to be the same bounding, to be honest. Oh, wait, but the length of the contour... Oh yeah, it'll be x2 minus x1. Both of these are going to infinity. You know, probably need some absolute values there. Um... Squeeze for the... Yeah. I'm not... I'm a little bit weirded out by how you bound this when one of the ends aren't 0. Sand Scar. I don't know how you solve that elegantly. I only know how to guess and check. Oh wait, no, integer solutions. No, I don't know how you solve that at all. Sorry. I was thinking of natural numbers where you can guess and check that. I don't quite know what to write in the denominator here. I'm kind of willing to drop it though. It's the one bounded by... Oh, with y? Oh yeah, I didn't need the absolute hours on the outside. I'm dumb. Yeah, PhD. I was like trying to figure out like there's too many constants floating around here for me to like figure out which one we want. You want to keep the e to the minus y on top though, Puika? I was just calling it 1. I guess either way in the limit, it shouldn't matter. Or if anything, it'll help us get to 0. Yeah, this is still weird when there's multiple variables going to infinity like this, but I would think you can split it up into 2 fractions with the x1 and x2. Well, yeah. And show they both go to 0. I don't know. I'm not entirely... I don't entirely know how that really works, but... Presumably we could do a similar thing for that third integral as we did for the one over here, or you just say that they cancel, I guess. I don't know. But that's really like the work of the problem done, because you can use residues to find the little dent piece there, and then these two integrals here turn into cosine plus I sine, and you just take whatchamacallit, the reals equal to the reals, the imaginaries equal to the imaginaries. So like, yeah. I don't know, like all some of the bounding these is really confusing to me. I kind of feel like I should be better at it, or like it's important to people to do. I don't know if it does either, Puika. I'm not really convinced by the, like, I feel like it should, but I don't know. Oh, Obi! Thank you so much for the raid. Welcome in, people. I hope you're playing against the Storm. I hope that was good. It's me. And only me. I'll take it. Yeah, no, for anyone who's here, check out Enzebux Pachinko. He also streams math. I think right then he was playing against the Storm, which is a pretty interesting looking game, but he also does math streams. I've been working on my complex contoured integration, and I've been doing the same problem in multiple ways because I just have been feeling masochistic today, I think. Finished one settlement tonight, started another, but fading. Yeah, fair. I'm probably going to call things pretty shortly here, too. Yeah, that's kind of what I've been doing, Puika. Gonna go downstairs, finish your tea, play Clear Obscure. There you go. Honestly, I think I might call it here in Raidon. Finish Act 1 last night. I'm dead. So someone told me about the game. It sounds really like up my alley. I want to pick it up at some point. At some point I will, but yeah, I think this is feeling like a good place to call it for me because I'm pretty like mentally tired. Oh, Syntax, you squeezed in just in time. What's up? If it's a hard question, I probably can't do it right now. I probably can't do it in general, but especially not right now. But if you want, we can still ask your question. My half circle. Yep. Existential horror, beautiful soundtrack, JRPG style turn-based combat. Yeah, and so I love turn-based combat games. I love like Dark Souls where you have to like block and parry things at the right time. And so combining those, I mean, you could mess it up easily, but it sounds cool. You know the tech to show the circle part goes to 0 as you increase the radius. Okay. Or is to show that. Yes. Well, yeah, for this outer this outer arc is going out to infinity. This inner arc here is going to 0. But yeah, the outer arc that gets big goes to 0. The skills give bonuses for planning out your individual character AP usage. Okay. Are there theorems for when that happens, or do you need to do inequalities every time? There are theorems. Jordan's lemma is the one that I somewhat precariously cited because there wasn't full agreement on whether it actually applied. I feel like it does apply, but I have a hard time justifying it. This is the actual statement of Jordan's lemma here. I think the arc they're talking about is just like that semicircular arc. And there's other theorems for when the radius goes to 0 too. Yeah, the inequalities are really annoying. We were just trying to do those with the rectangle one, and it was terrible. Male, I'm sure I'm pronouncing that wrong, is a fencer. So if you plan out her stances around to her ahead of time, she gets reduced AP costs or increased damage or many other things. Ooh, that's pretty cool. Yeah, U2 syntax. Mayel. Okay, that makes more sense. um so yeah, tomorrow I'm streaming math today because I will not be streaming tomorrow at my usual time. If I do stream tomorrow, it'll be in the evening and it'll be playing games. So that's why I'm doing math today, which is out of the ordinary for me. But yeah, the YouTube stream is going to get cut off here. So anyways, here on YouTube, thanks for being here. Back on YouTube on Tuesday.